Hello, I'm Dan McVaugh, and this is Connectivity Evolution. Imagine a world where the entire global internet infrastructure runs itself, detecting and fixing issues, rerouting traffic, and scaling services on demand. That is level 5 autonomy. And it's not science fiction, it's what Google and other telcos are working on and chasing today. In this episode, I'll delve into Google's ambitious plan to achieve level 5 autonomy for its vast fiber network by the end of 2025. We'll explore what this means for the industry, the role of AI in network management, and how this move could redefine the future of data networks. Google this year announced plans to fully automate its 2 million mile fiber network with the help of AI agents, digital twins, and protective reroute technology. Google's extensive 2 million mile fiber network is the global infrastructure that they use, and that underpins their services such as Google Cloud, YouTube, and Search. It's one of the most extensive and advanced fiber networks and data networks in the world. And Google has always been known as a leader in technology evolution, and this is no different. First, let's start with TM Forum. TM Forum is a global industry standard agency that has set the standard for autonomous network maturity models. That network maturity model defines 6 levels of automation by which networks can be classified to determine how manual or autonomous they are. So let's look at those levels, starting with level 0, which is fully manual operations. It's kind of historically how many networks have started from the inception years and years ago. And that basically means all tasks in the network are performed by humans with zero automation. If we then go up to level 1, there's some assisted operations with some automation introduced, mostly just in the case of alarms, dashboards, and notifications, but then humans have to analyze and make all the decisions and act on them. Moving up to level 2, this is called partial automation. And this is a situation where the network has some automatic functions such as predefined rules with some basic scripting, but there's still predominantly human oversight. But there are some intelligent functions that are pre-scripted or pre-designed. Then we get to level 3, and this is where automation starts to get introduced. This is where there's more complex automation, including some basic AI or machine learning. But humans are still in the loop. They're setting the programs and the rules for any final decisions to be made. Then we go to level 4, which is considered high automation. This is where most functions are automated, with humans only occasionally intervening. The AI system can learn, and it can adapt to changes in conditions. And then finally, level 5, the highest level of automation, called full autonomy. The network is fully autonomous. It can monitor, manage, heal, and optimize itself without any human involvement. Decisions and actions on the network are executed automatically, guided and controlled by AI agents, digital twins, which I'll talk about, and real-time analytics. Human input is really only required in these systems for high-level policy setting and for rare exceptions. For example, when physical changes have to be made to the network, i.e. digging up a piece of fiber and repairing it, things of that nature. So this is the level of autonomy that Google is striving to achieve in its global fiber network this year in 2025. So let's talk a little bit about what that would mean for them. First and foremost, it means that their network is now self-driving network operations. The operations of that network is all done autonomously on its own. So the network is continuously assessing its state, predicting issues, and taking corrective action in real time. It's the same function that has been done by humans over the years, but by buildings of engineers monitoring alarms and status, technicians sitting in a network operations center, looking at alarms, looking at monitors to determine what needs to be done, then analyzing those things, and then manually making changes to the network, a process that could take hours or even days in some cases, which I've experienced in managing wireless networks in my career. In this case, the self-driving network operations would happen in a fraction of seconds, if not minutes at the slowest. Big difference. And the big difference here is that AI is the driving decision maker in these advancements. So machine learning and AI are now using the ability to adapt and learn more about the network, a process that could take humans years or maybe never happen because they have the ability to consider multidimensional aspects of the network, which is much more difficult for an individual. And then at the end, this allows for what's called end-to-end orchestration. So the automation can span multiple layers of the network from the physical layer all the way through application layers and higher levels of the network, and then across geographies to understand the impact of a change in one geographic location or one layer within the network to another layer geography in ways that are more complex than humans typically can do quickly. And then lastly, it adds zero touch operations. All of the provisioning in the network, all the troubleshooting, the healing, and the scaling happen automatically. Humans are effectively out of the loop operationally. They can audit, they can guide the system through high level policy changes and make changes when it's not working right. But it's, for the most part, day to day, minute to minute, second to second, millisecond, and microsecond to microsecond changes are being done automatically by the network itself. So the best way I can describe is what this really means in an analogy is achieving level 5 autonomy on a network is very similar to, say, going from a human-driven car to a self-driven Tesla that also repairs itself on the go. So it doesn't just drive, but it determines that it's got a flat tire, pulls itself over, fixes the flat tire, then continues on driving, or changes something else in the motor or any other part of the operational car on its own without any human interaction. That's what we're talking about with level 5 autonomy on Google's fiber network. What does this mean? It means massive efficiency gains, rapid deployment and scaling of new network, very resilient to outages, better customer experience because things are taken care of more quickly and more effectively, and of course, lower operational costs. So what are the implications of this? It means that the network is going to detect anomalies in the network. So it's not just problems, but unique occurrences and conditions that might make the network less efficient. And it'll proactively optimize that network. It'll increase reliability, stability, efficiency in the network, but there's always downsides and unintended consequences, and that'll remain to be seen. But I think some obvious ones could be around cybersecurity, for example. What happens if the autonomy in the network, the digital twins, the things of that nature, are hacked by bad actors? And that could cause the network to not work the way that we would want it to. There might be some ethical concerns. And of course, there's still need for human oversight. So it means a significant impact to workforce development. How do we retrain workers to have new functions, new tasks to manage and oversee this autonomous network? Now let's talk a little bit about what the basic elements that I mentioned earlier mean. So we talked about AI. I think a lot of people know AI has been used and mischaracterized in terms of how autonomous the network really is. A lot of what people are calling AI really is just machine learning or even lower levels of pre-scripted decision making. AI literally truly means that the system is intelligent and it can learn and can adjust its rules and adapt on its own without human intervention. AI agents are like control nodes and control processes that can take on specific tasks and learn. So a good example that people use for AI agents is things like having an AI agent to manage my business travel plans. My schedule is known, the dynamics of my schedule is known, where I need to go for business travel is known, and the agent then scours the world to book my trips for me, uses rules around things like my frequent flyer miles, my personal preferences, learns about what I like and dislike, adapts accordingly, and then rebooks, reclassifies, saves me as much money as it can. Those are examples people are using of AI agents. Digital twins are basically a digital duplication of real world elements. So in this case, it would be a very highly detailed digital copy of Google's fiber network, including all nodes, all aspects, all physical devices, all physical fiber, locations, route miles, all of these things, including all of the settings inside of every element, switch settings, router settings, all of the above. That digital twin can then be used by AI to make changes virtually and analyze what it thinks might happen as a result of those changes so that it can basically be a test bed for it to do trial and error and learning without causing problems in the real network before those changes are made in the real network. It also allows conditions in the real network to be mapped and simulated automatically so that the AI is more effective. It's sort of a test bed, if you will, and a representation of the real world and the digital world. And then lastly, protective reroute technology. So what this is this allows the network to sort of proactively know things like a storm is coming. I'm going to proactively figure out how I might need to reroute traffic if I take a power outage or a lightning strike on a node, things of that nature. And it gets into much more complicated, complex situations that are not just outage based, but performance based. It can slice the network logically into different layers based on applications going over the fiber. And it can say, hey, I'm going to reroute some of this traffic that's real-time, high bandwidth video over one route in the network and maybe keep lower level, low bandwidth, low intensity data and route that through another network, that part of the network that's having problems, that it's not susceptible to those problems, things like that. So this protective reroute technology is the fourth piece, and that's how that would work. So it's easy to see that this could have phenomenal impacts on the network and really change the way that these networks work in our world and how it impacts us as users of those networks. So it'll be interesting to keep an eye on. I think that it's important for us to be considerate of these changes and learn how we would adapt to them. I'm excited about it, and we'll see how it changes across all levels of telecommunications. It's something that I've been thinking about and looking at in my industry, in the wireless telecommunications industry that I've spent most of my career thinking about things where we could use autonomy to optimize the network, fix changes in the network, shed traffic off of one cell site, blossom onto another cell site, things of that nature. So I encourage you to think about how these types of changes and keep an eye on what Google does and how that could affect all of the different types of data and telecom networks that we all use and rely on a daily basis. For now, I'm Dan. Thanks for listening. This is Connectivity Evolution.
Thanks for tuning in to Connectivity Evolution, the podcast that explores how technology enables human connections. If you enjoyed this episode, be sure to hit that follow button and be sure to share with your friends and family.